This video will be about factoring when a is equal to 1. Now what I mean by a is that a standard form of a quadratic equation looks like this, where a, b, and c are usually some kind of numbers. So you'll see that a is the number that is in front of the x squared term. So when a is 1 gives us our most simplest form of a trinomial, such as you see here in example a, where there's no number in front of the x squared, and if there's not a number there, then it's an understood 1. And this gives us the most basic types of factoring when it comes to factoring a trinomial. So now let's talk about what I mean by factoring. So most people are pretty familiar with, if I were to give you a set of binomials such as these and told you to multiply these together, then you know to go through your FOIL process and do x times x, which would give me x squared, x times 3, which would give me plus 3x, 2 times x, which would give me plus 2x, and 2 times 3, which would give me plus 6. Then I would need to combine these two x terms in the middle to give me x squared plus 5x plus 6. So you can see that I took the two binomials, multiplied them together to give me a trinomial. Factoring is this process in reverse, whereas instead we start here with this given trinomial and want you to break it down into the original binomials that I used to multiply together to get that trinomial in the first place. So the way to figure that out is by following this little formula. So since I know I'm going to be breaking this into binomials, I'll go ahead and set up my first pair of parentheses. So from here, now I'm going to make a little t-chart to keep my numbers organized. So keep in mind that a, we already discussed, was 1, right? The number in front of x squared. B in this case is positive 2, and c in this case is a negative 24. So the way I'm going to decide what factors I need to use in my binomials is by looking for what multiplies to give me my c term. So in this case, what's going to multiply to give me a negative 24, and what adds to give me my b term. So what adds to give me a positive 2. So from here, I'm going to go through listing all factors of negative 24 that I can come up with. So keep in mind that since 24 is negative, it means that one of my two factors has to be negative, because when I multiply a positive times a negative is the only way I can get a negative answer. So thinking through my factors, I know I could have either one of them be negative and either with the other one being positive. So I go through here and list all the factors I can think of that will multiply to give me negative 24. Oops. Sorry. And then I start summing these together to see which of these are going to sum to give me 2. So for instance, 1 and a negative 24 gives me negative 23. That's not what I'm looking for, so that's not the correct combination. Negative 1 plus 24 would give me positive 23. Also not what I'm looking for. And I would continue going through summing all of these terms until I found what the correct combination, which in this case is the very last one I wrote down, negative 4 plus 6 gives me a positive 2. So since that is the correct combination, negative 4 and positive 6 are going to be what I use to fill in my binomials. So I should have x minus 4 and x plus 6. Now keep in mind, since this is reverse foiling, that I can always check myself by foiling my answers at the end and make sure I get the trinomial I started with. So x times x would give me x squared, x times 6 would give me plus 6x, negative 4 times x would give me minus 4x, and negative 4 times 6 would give me minus 24. Then when I combined my two like terms here in the middle, I would have x squared, and a positive 6x minus 4x gives me plus 2x, and then I bring down my minus 24, and you can see that is the trinomial I started with, so it means I factored this problem correctly. Go ahead and pause the video and try the second one on your own. Okay, so we'll start off with this the same way that I know I'm going to break this up into binomials, so I'll get that set up, and then I'll get my t-chart drawn, and then I need to identify my pieces here. So A is 1 again, B in this case is a negative 10, and C will be a positive 16. So I'm looking for what multiplies to give me C, which is a positive 16, and what's going to add to give me B, which is a negative 10. So again, I come in here and start listing factors of 16. Now in this case, since 16 is positive, it means that either both my factors are positive or both my factors are negative, because a negative times a negative will also give me a positive answer. So I could have positive 2 and positive 8, or negative 2 and negative 8, or positive 4 and positive 4, or negative 4 and negative 4. Then again, I would start summing all these up to see which one's going to give me a negative 10. 1 and 16 gives me a positive 17, not what we're looking for. Continue summing until you find the correct combination, which in this case is going to be negative 2 and negative 8. So then I come over here to my binomials and plug this in. X minus 2 and x minus 8. And again, you could FOIL that back together to make sure you have the correct answer. On this next video, you may notice that A is not equal to 1. It's equal to 3. So this is where you may want to pay attention to the hint I gave you at the beginning of this worksheet, is to make sure that you check every single problem that you're going to factor for a GCF first. It will make your life a lot easier in the long run. So for instance, this one, what I mean by a GCF is I'm looking for a number or variable that I can divide out of every single one of these terms. So in this case, I notice that each of these terms are divisible by 3. So 3 will be my GCF. Now, a common mistake when working with a GCF is to divide it out of the problem and make it disappear. You can't do this. You must make sure that the GCF is in your answer all the way to the end of the problem. So what we do with the GCF is we write the GCF on the outside of the parentheses, and then come in here and divide the GCF out of each of these terms individually. And what's left over after I've divided the 3 out of each of the terms is what goes inside the parentheses like this. So 3x squared divided out by 3 leaves me with an x squared. 15x divided by 3 leaves me with 5x. And 18 divided by 3 leaves me with a 6. But notice that the 3 is still a part of my answer. So the GCF will no longer have any part on my factoring process, but it does have to follow me the whole way through until my final answer. Okay, so now from here, looking inside the parentheses, I now have a trinomial where A is equal to 1. So I can go back to my process of making a t-chart and looking for what multiplies to A, which in this case is multiplies to C, which in this case is a positive 6, and adds to B, which is a positive 5. So again, I go through listing all my different options of factors that will multiply to give me a positive 6 until I find the correct combination that will add to give me a positive 5. So when I'm looking through my options, I can see that 2 plus 3 will add to give me a positive 5. So that's going to be what I use. So then I come back to my parentheses and I have x plus 2 and x plus 3. And here's my answer fully factored, GCF included. Okay, so now let's look up here at problem D. And this one, again, may look a little confusing because not only is A not equal to 1, but I'm also working with an x cubed instead of an x squared. So that's where, again, I would want to make sure that I'm always checking for a GCF first. And in this case, you can see that not only do I have a GCF of 4 that divides into all 3 of these numbers, but I also have an x that divides into all 3 of these terms. So I'm going to use a GCF of 4x. So the GCF gets written on the outside of the parentheses, and then I need to divide the GCF out of each of these terms. And what's left over after I divide is what gets written inside the parentheses. So 4x cubed divided out 4x leaves me with x squared. 8x squared divided by 4x leaves me with 2x. And 60x divided by 4x leaves me with minus 15. Okay, don't forget to bring your 4x down with you in this problem and let it be a part of your final answer. And from here, looking inside the parentheses, I have a trinomial where A is 1. So now I identify that C is negative 15. So I'm looking for what multiplies to give me negative 15. And B is a negative 2. So I'm looking for what adds to give me a negative 2. So listing factors of 15, and since 15 is negative, means that one of my two factors has to be negative. And thinking through everything I can come up with, that will multiply to give me a negative 15. And then as I go through the summing process, I'm looking for which one's going to sum to a negative 2. And it's going to be this one here with a positive 3 and a minus 5. So that's going to give me my factors of x plus 3 and x minus 5. And here's my answer completely factored. When I come down to problem E, you may notice this one looks a little different because the term in front of x squared, my a term, is negative. It's really important that you make sure that your x squared term is always positive before you start factoring, or else you're likely to make a mistake. So the way I'm going to handle this one is by treating this as a GCF, where my GCF in this case is going to be negative 1. So if I bring a GCF of negative 1 outside my parentheses and divide each of these terms by a negative 1, it'll fix my sign issue where I'll now have a positive x squared. Because negative x squared divided by negative 1, it gives me positive x squared. Negative 5x divided by negative 1 gives me positive 5x. And positive 36 divided by negative 1 gives me minus 36. So now remember that the GCF is still part of your answer. However, it's not necessarily to write the 1. So you'll see me just leave it as a negative outside of my parentheses. And then from here, we make our t-chart, and we're looking for what multiplies to C, which is negative 36, and adds to B, which is positive 5. So as I'm thinking through different factors of 36, knowing that one of them must be negative because 36 is negative, and there's a lot of factors, so I'm not going to list all of them, I'll just list a few here until we get to the right combination. And I see that 4 and 9 is going to be a good choice. However, I want to make sure that 4 is negative and 9 is positive so that I end up with a positive 5 when I sum these. So then my binomials become x minus 4, x plus 9, and there's my answer completely factored.